Hello and welcome back to the next video in my game engine series. Now in the last video what we've done is we have done a bit of madness with DLLs and how they are loaded. What I want to do today is I want to start writing a build system in the engine. Now we're going to do this by first exploring a bit how we use the DirectX 12 shader, and then we're going to find some like common interface that we need for like fueling the shader and to finally writing the output. And then when we are finished with that, depending on how fast this goes, probably it's already the next video, we're going to start incorporating that into a engine build system. Alright, so let's get directly started and let's start with compiling a shader. Now, I'm not personally a fan of putting everything in the update method. I think we should have an init function, right? We have the... We just have the update? Really? We have the... Where is my interface? Here, basic layer. But the layer should have a... update draw on attach. So I think we could use the on attach function. Maybe we should also add it on init. Let's quickly add it on init to the layer. So we have the update virtual bool init. So an initialization function. Okay, so init the layer. I mean, I think the on attach would be more, because I don't know. Now let's maybe completely implement this, because layers are currently not really aware of the state, so we could detach, attach them all around how we would like. So maybe let's just put it in the on init. So void on the on attach, I mean. Let's maybe just make it like that, and if it fails, we can always just throw. Let's just put it in here because I just don't like the pattern that's emerging here. Okay, right. So how do we now compile a shader? Let's go back to the docs here and let's see how they use it. Okay. So how does it work normally? So you have the utils and you have the compiler that are both created. I mean, why not? Why not? Let's just grab both of these. Maybe we need them, maybe we don't. Let's first completely write everything, and then if we see that we maybe don't need one of the other, then we can later on remove them. Yeah, okay, so what they are doing is they're using this include handler. We don't need the include handler now, but the thing of the include handler is, if we would take a look at that one, at the include handler. So the include handler basically, I think, allows you to load the source, file name, included source, loads the source file to be included by the compiler. Okay, so it's really not what I was thinking about. I think the include handler was... I don't know what the include handler is. I think I thought that might be the handler that is called when an include is called, so that we can go to the right path. But yeah, as it seems like it's not. So basically what happens with the DirectX shader compiler is that it, with the library, is that it needs to, specify all the arguments. So normally what you do is, you have the arguments in the compiler, right? We used that in Visual Studio Code here, so we added the arguments in here, and basically we do the same with the compiler as well. So they are just defining the arguments there. It's just a list of strings, so we could also use an std vector of w strings, so we should probably do that. So std vector, how do we have them? Since this Windows is going to be all wide strings, vector and wide string is not a thing. I'm just going to include them now all in a blob because we're later on going to move them somewhere else. What? There it is. Why do you have a problem with the v string? Interesting. Why is std v string? Peak definition? Vector. Why the hell? Basic string, it should be defined in X string. Why is it? Is it really an X string? As it seems it is. Okay, so then let's just include X string and say that we want to have a W string here, and then we can just supply the arguments as an initializer list, right? So we can just supply them like that. Just makes that a bit more modern C++ instead what they have here. We need to have always the name of the shader. This is really, it seems a bit odd to have the name of the shader in here because we're not loading it from file actually, because, yeah, but yeah, I would still recommend that we would do that. So we will start with our dummy HLSL like that. Okay, so now we have our dummy.HLSL, and maybe we're just going to copy all of the functions in here so that we can just go through them step by step and see what we do. So now first, this is the entry point of the shader. It's already in here. So the entry point is kind of like the main function of the shader. Then we have the target, what kind of shader we are using. I think we used the vertex shader 6.8. So we also want to use that here. Then what we define is ZS. This means enable debug information. Then this one is defining a macro. We don't need a macro definition here for now. And if you are defining the debug format or the information, this case the slim format, it would help you if you have a graphic debugger to kind of like see what's going on. So you would kind of like get an information on what's really going on if you are like on debug or not. I think for now we could just have the debug information there. Why not? Let's just have them. Okay, so now what you need to specify is a few information. So you can define the file output and you can file the file debug. If you don't define the debug, I think it's embedded into here. So stripping debug informations is most of the time reasonable, because if you want to ship an application, you might not want to ship the debug information with that. So that's actually okay. So we can have that as a PDB. Now binary, I like to call this one CSO, compiled shader output. We could compile this SD or compiled shader debug, or PDB is just kind of like a common way program the debug or yeah, database, debug base, whatever. Yeah, but I think for now we can just call this like that. I don't need these comments here. They are just populating our code. Okay, and then what they are also specifying is QStrip reflect. So basically what the shader has is shader has reflection information, and actually these libraries also allow to later load a blob and to reflect the blob. If we would go in here, I'm not sure if it's in this header, but I think there should be also the ways to specify that, and actually you can see that there even defines for the arguments, some of the arguments. I'm not sure if reflection is in here. No, it's now searching already here, but there are definitely in the library some. I think the reflection is actually here in the shader. The shader one. It's like the semantics. Yeah, exactly. You can see the semantic name, index, registers, buffer descriptions. These are like defining the reflection informations. These are all the structs that are used for reflection and ID3rel function parameter reflection. So all the reflection code is kind of like in here, function reflection, and then you can later on reflect over the shader. And this reflection information can be stripped from the main shader blob. I don't know, we don't need it, but it's always good also to have it stripped. We can just get rid of these. Let's just start with a simple example like that. Okay, so now that we have our arguments here set it up, we need to kind of like now open the source file. As you can see, really what's happening is like some encoding and decoding. we don't really need these actually. This is like opening a source file with DirectX 12. I do just want to quickly open it myself. So what I want to do is I want to have an std if stream again, shader file, and the shader file will be if stream is not included. Did I not include that? Was it somewhere else? Right. This was somewhere else. Okay, so I'm going to go into content, shaders, dummy.hlsl. So I'm going to open it here. And then let's have an std vector of chars and call this one shader data. And then what I'm going to do is I'm going to say shader file.cg std ios end or 0 to end. And then back to the beginning. And in here, I'm going to say shader data resize. I'm going to resize the vector to shader file telg. And then what we're going to do is shader file.read. So now we are reading the data. We are reading this to shader data.data, and we're going to get the size that we want to read also from the shader data blob. So this should read the shader into memory. I'm not sure. I think we need to actually define this now as a buffer source. UTF-8, so RCP, DXC, CP, code page RCP. We need to always have that into that buffer, so shader buffer. We need to define that one. This is basically, it should be just a very, very simple struct. That has like a pointer, a size, and the encoding. And what we want to do, let's initialize that one. And what we want to do is we want to set the pointer to shader data.data, shader buffer.size to shader data.size, and shader buffer.encoding to the DXC CP RCP, how the example suggests. And now we should have all the data ready. Now what we can do is now can compile the source. So how are we going to compile that? So we're going to compile it by calling the compile function of the shader compiler. We have the source, we have the arguments, we have the number of arguments, we have the include handler if we want one, and we have a result which is of that kind. So that's the result. Com pointer, so how did they call that? P compiler, DXC compiler, DXC utils. I like the my naming conventions more. I think we don't even need the utils now. Let's see if we later need them, but I think maybe we can get rid of them. And now this is the DXC result. And now the compiler, we're going to call the compile function. We have a source, which is the shader buffer. Then we have our arguments. Our arguments will be args data. I think we should be able to really const expression std. Yeah, because these are now W strings. That's not so cool. Let's just make them const which pointers quickly. So this one should work. Problem is that it cannot deal really with W strings, so we would need to transcribe it again. But the nice thing is that we can use now the size function. We don't want to have an include handler, and then we have IID PPV args as we know it to the result. And this function should also return an H result. So if we go to position R1, H result, DXC result code, so the resulting code that we have, then we should already get some information. So that is actually everything that we need to compile a shader. We need to load it, we need to transcribe it into that buffer, so maybe I make a breakpoint even before we execute, and we need to have all the objects. So let's just run that and see what we got. If this works, if we have any problems. Why is it compiling so much? I don't know. Alright, so let's quickly inspect. I do just want to quickly inspect the buffer. So we have a certain size, we have an encoding, and we have a pointer, which already looks good. If we look at the shader data quickly, and if we view that, you can actually see that our shader is inside the application. So this seems good. So let's run the shader compile, and we are getting an SOK. And I would say if we get an SOK from the compile function, this means that we compiled successfully, I would say. We could try to fool it that we not get an SOK. Let's try to not get an SOK. How can we not get an SOK? We're just going to very stupidly define something. Just beat your keyboard a few times and just try it out. Now we still get an SOK. That's interesting. Okay, so it could be that it's just a function call that we are catching here. It's quite possible that this SOK is just telling us that it ran correctly, but maybe if I go to my result, yeah, has output is probably what we want to have. Get error buffer. Let's just quickly get the has outputs and dxc out kind. What is that? Dxc out. I think there should be something called bytecode normally. Shader hash, root signature. I don't know. Disassembly errors, false, last, none. Let's see what they are doing. I think they are checking. They have the error blobs, and then they get the output or the errors. They can get the status. Yeah, then let's get the status. We don't really care about the errors. Let's maybe first get the status. C compiler status. So let's get the status here. And there's the get status and dxc compiler status. So E not implemented. Let's put us to that default status and then let's see what we get. Now you're still remembering we have the wrong code in here. So I would imagine this one is failing. Okay, so we now get the status E fail because the compiler failed. That's good. It failed because it could not compile. Okay, so let's now remove that garbage here and let's see if the compiler now can succeed. Okay, let's see. And we are getting an SOK. Super. This works. So we already know if it failed or not failed because of the status that the compiler gives us. Really good. Okay. So this works. So let's now dive a bit deeper. I don't care about the errors. We should have them, of course. But what we really care about is the shader binary and the shader PDB. And I think they're also printing the hash. And they are getting the reflection somewhere down there. And then they can output the reflections. And then they can create a reflection. And then we could use the reflection interface here. So the ID3D12 shader reflection. If we are creating that one with the reflection data that we have in the buffer here that we are getting from the get output function of the result, we could use reflection on the shader, which is really something really helpful. Light reflection and things like that is something, if you have a more complicated project, reflection is key. Reflection is really important. What we care about is we care about like this code block. It's not this one. It's the same than here. It's both just a way to get an output from a shader. Let's maybe first just do it with the binaries. We don't really care about the PDB yet. So basically what we need is that section of code. Just rename this to the com pointer. Okay, so we have the shader and we have the shader name. We don't need to initialize that because our com pointer does that on our own. And then what we just do is we're going to get a shader blob and shader name blob. So we have the shader blob that we need. It goes here. And there's the shader name blob. It's interesting how it's doing that. And I don't like the UTF-16. Let's do it a wide one. This is like what it's accepting. It's probably the same one. Yeah. Okay. So this is the enumeration that we need. Okay, so now we should have our data in the shader blob. And I think we should get the buffer pointer, the buffer size is exactly what we want. So let's make an std of stream as an output stream, shader out. Okay, shader out goes to /content shaders dummy.cso. The name should be probably also encoded here. So yeah, actually we can get the name. Let's get the name from here. Let's make it completely different. Let's make it std file system path so that we get it here. Okay, no. Is it not included? File system, there we go. Current path, okay. Content shaders, that's where we want to go. And then we want to have the name. Can we just get the string pointer? Probably. We can just get the string pointer here. Okay, this is going to be quite a long line, so maybe let's make it like that, just that we go in here. And since this is binary, let's just put this into binary mode as well, so that we have a binary shader output. Okay, so now we have the shader out, and maybe let's also truncate that, std iOS trunk, like that. And then let's go to shader out.write, so that we write some data. We're going to write the data from the shader blob get buffer pointer and shader blob get buffer size. That's what we want to get. And this one is, I think, a LP void. So const char pointer is what we really want to write to the file. Now that's everything that we would need to just compile a shader by calling some code. Okay, so if we go back to VS Code, let's just quickly make sure that the CSO file is deleted. Okay, so that we are not fooled. So dummy.hlsl, no other files are here. Let's run it. And let's see if it explodes on us or if it works. We hit a breakpoint, that's good. Could quickly take a look at our, I don't think that I can take a look at these ones. But let's just go and continue on so that the files are actually closed, the file handles. And let's go here and see what we got. And who has thought about that? We have a dummy.cso. And it looks quite good. It has a dummy. It actually references now the dummy.pdb that we don't have here. You can see we don't have a PDB. It's referencing that, however. So it says we have a dummy.pdb. We have the SV position, we have the main, so it seems like a good shader. DirectX intermediate language, I think, or intermediate layer, or how is it called, so it seems good. DX entry points, it's referencing main somewhere, or is it after the main? So yeah, I don't know why I always try to reverse engineer what they are doing in binary file formats, so here, I don't know what I'm doing. But yeah, they're doing stuff, right? It seems legit from just what I see, from the strings that I have and everything. Okay, let's quickly, just for convenience, we can do this for the PDB. Copy paste this. PDB blob. PDB name. Well, actually we could just reuse the old objects, but nah, let's not reuse them quite now. Let's just do it the simple way. Name blob. PDB out. The nice thing is you could just write a uniform function that does these output writings based on these two blobs. That's the nice thing, right? You can just write the function once and it will work all the time. Okay, like this. Let's run it again. Let's see what we get, if we get a PDB, and how the PDB looks. Nice, works. Did does something. Do we have a PDB? No, we don't have a PDB. Ah, why do we not have a PDB? That's not so cool. Where is my PDB? Okay, so what did I do wrong? PDB name blob. Ah, hey, yeah, exactly. I know what I did wrong. I still get the data. DXC out PDB. Of course, we need to ask it to get the PDB. If we don't get the PDB, we are not going to write a PDB. Okay, let's see. And there we go. Now we have the PDB. Can we open it up? Microsoft, CC++, MS, V1.9, DS, PHQ, whatever. What's in there? We don't know, but it looks different, right? DX entry point. It looks similar but different. Dummy.pdb, dummy.cso. So you can see that the PDB is now referencing the right also CSO file. And if we want to look at that, dummy.hlsl, then we even have the source file. So yeah, looks good. We have everything that we need. We have a source, we have a CSO, we have a PDB. I'm not even sure. Do we have a shader PDB viewer? Can we just drag and drop that in Visual Studio Code? Or not in Visual Studio Code, in Visual Studio. Can I go and try to open that? Cannot do it. Okay. So it goes into a binary viewer. That's cool. That's okay. We cannot really view it, but we could view it if we have... I don't know if you can do it standalone if the shader is not loaded with a graphic application. But trust me, we're gonna later on explore how it works without the PDB and with the PDB in graphic compilers, because they are able to read them. If we are working with pics, or if you're working with... I think I installed them already, right? We already played around with pics. If you're working with pics, if you're working with inside graphics, they can read these files. They can read these PDBs, they can read the CSO files, and they can give you information. So if you just have the CSO, it's just going to show you the instructions, the like raw instructions that it can do. Attach the PDB to it. It can give you a bit more information, and I think also symbols. And as soon as you have the source attached to it as well, you can see the source. So it's really helpful. So yeah, that's what we did today. Now what we need to do is we need to make this into a build pipeline. And I think we are not going to do it in this video. But what I want to do is I want to quickly go over that and find a few learnings. First of all, the first learning is we didn't need a util one. So there is a way. But that's not what I wanted to go to. What I wanted to go to is to have like a learning on how it works. So in general, we have an input file. Our input file is the HLSL file, right? This is what we want. Now, this HLSL file, in order to translate that, needs some translation descriptor. In this case, it is the arguments. So we need some arguments. We need to know what kind of file this is in order to run that. Now, how could we do that? Well, what I think is we're probably not going to directly trigger on HLSL files. We're probably going to have some descriptor on that, but maybe not. Maybe we're also going to maybe try something else, because as you can see currently we could generate all of that just from the name, right? We know the name dummy, we know CSO, we know that we name it PDB, we know that we might need debug, and we might know that the entry point is called main if we do not like explicitly override that. So but we could work with just main, right? The only thing we can currently not take for granted is the type of shader. So we need to find some way of either inlining all of these arguments or more or less probably just inlining these two. These are automatically generated depending on how we build. This one is automatically generated. We could just change our naming conventions and just name files like that, right? Would be quite similar, right? You just add it to there and then it knows what's going on. Or what we could also do is we could just use some comment at the first line that is telling the configuration. But maybe that's something that we talk about in the next video. But we need to have some way of encoding that. So what we're going to have, we have some files and we're going to have some metadata. What are we doing with these? Well, we need the data of these files somehow. So our API needs to be able to provide the data. Then we are going to have some core that processes it, like this one. This is like the core, or maybe even with that one, that processes that, and then afterwards we are going to produce artifacts. So our build pipeline is going to be somehow input file or input files, process artifacts. And yeah, I think really this is going to be a bit of a problem how we're going to implement that, because we need to find a way to uniformly define these. It's not going to be a problem, but I will need to think a few minutes about that, and then I'm just going to record the next video where I'm going to go and present you with the solution on how we do it. So yeah, thanks for watching. See you in the next one. Make sure to like and subscribe, and have a nice day. Bye.